Hello everyone. Today I wanted to talk about uh, using automated HR analytics uh, with AI agents in work and graph neural network. Graph neural network is different from other kinds of ML or DL models. Um, Let me just share my screen and it's real thing. So this is the Git repo. I just quickly explain uh, graph neural network is the deep learning architecture, but it's unlike traditional neural networks. It works in it takes the collaboration inputs too. For example, in an office, you have a team, and graph neural network also takes account for the individual for the team collaboration, employees collaboration, and their performance metrics, etc., along with uh, the individual inputs. So let me show quickly the data sets. For example, this was our employees data set. We have ID, experience years, performance rating, hours worked, and skills. Uh, with that, we had interactions for projects, interaction about between two people, uh, project ID, yeah, communication frequency, collaboration strength, and all that. So we had these two data sets basically. Oh no, no, one other data set was projects, the project's IDs, and all the details on the project. So what we had, actually, I can show it from the data as well. So Y graph, we could have built a model, just normal ML model, right? But what graph does is really interesting. Graph um, takes the collaboration level among each other. So when you're predicting any performance for someone in a team level, you also want to take account the collaboration level. Uh, how do the players or the team members are working together as a team? So for HR analytics or team analytics, what you will call, this is also an important metric. So we also want, so that is why graph neural network is a different sort of model uh, which takes this into account as well. Uh, yeah, so communication patterns and performance of connected employees, whom they have worked with, etc. They also do that, take them into account. Um, so the network effect takes place. Like network effect is also there when it's building the model. The performance of the network and strengths and collaboration. So what we did, we pushed the data that we had as CSV, we pushed that data to a graph uh, database first, right? So for that, we use Neo4J. Uh, yeah, for example, if you want to see which employees collaborated with each other, and if the performance gap is less than 0.5. Now the performance gap we found out the performance gap with the use of graph neural network. Our graph neural network first predicted the performance that a member should have right now, and it determined the performance gap because it has the actual performance score right now, and also by that, using the neural network model, it can predict the performance score that a person should have right now, and it and we can easily find the performance gap with the two actual performance score versus predicted. So if someone's performance score is less than 0.05, yeah, it just color codes and everything. For some reason, for some reason, yeah, in our Neo4J Neo4J graph, we are not seeing the color codes, but we have this one. Uh, we also used GraphViz, a library which produced this graph, and each of these nodes are employee and their performance scores. If someone's performance gap is very high, they're marked as red. If someone is doing good, then they doing good comparing to what our graph neural network predicts they should be performing. If they exceeds that score, they are marked as red. And if someone is near the predicted score, they are yellow. And most of the people are yellow, and there are only two people who are underperforming, and only one is the champion in the team. So in Neo4J2, we can show this kind of data. Example, I want to see, these are the employee IDs on the yellow nodes, and the score that's written here, the uh, the collaboration strength, I think, yes, the collaboration strength, how they're uh, collaborating with each other. That's the strength. You can show other performances, other metrics too, like communication frequency, right? Project IDs and everything. So in a graph, that is the beauty of graph. You can see things, and you can realize how the team is performing with each other at the holistic level. But if that's something very messy for you, then you can also go through something like this. So you can basically, so we did this. We pushed the data to Neo4j graph database, and we performed query. You can perform any type of query here, and yeah, you'll be seeing the graphs as well. If I go to the Explore tab, uh, uh, messy, messy, messy. Okay, let's find out something. Let's find out employees who has collaborated with uh, people who has collaboration frequency uh, greater than greater than 7. Okay, we have that right. So these are the people who has collaborated with each other and whose score is greater than a particular number. Uh, right, right, right. The employee who has predicted performance less than or equal to for research. Yes, you get the idea. You can basically query and explore data in graph database where you have a team performing if, rather than it is very different than the other use cases. When you're seeing something as a team, as a cluster, which is related to each other, uh, graph data is the choice for that. So finally, what we did, uh, we analyzed the results ourselves after pushing that data into the graph database. uh, we analyzed the results ourselves and what we did is we created a model first. Yeah, just so from the CSV from the CSV data that we had, we created the nodes and edges, right? The two main components of a graph, nodes and edges, and we created the graph neural network model. This network actually uh, predicts by the data. Actually, it actually predicts what performance score uh, an, an individual employee should have by this time, considering the collaboration and the strength and the experience, years working hours, seniority level of seniority, juniority, anyways. So all these factors, the graph model takes into account and gives you the actual score it thinks that person should have. So then we can find the performance gap, the actual minus predicted score, and that's how we analyze things. Now, after that, uh, we also pushed that predicted data to the Neo4J database, and then we pull the data from the Neo4J database, from the graph database, and we analyze the results ourselves, which is nothing fancy. We are just querying the weak collaboration, the like, other things like mentorship, who can mentor each other, uh, interesting things uh, using the cipher query from the graph database, right? And then let me show you the results of this script. So after running the script, we get a team performance analysis, the average performance of the team, predicted performance. Well, the predicted, it looks like the team is doing good, right? Because the predicted one was 3.43, but the actual average performance is more than that. So that is that. There is also performance loopholes that we can get, Let me show you the script for that. Performance loopholes. This one. So if the performance gap is less than negative 4.5 and the performance years is more than 5, means that an employee is working more than 5 years in that company, but the performance score gap of the difference between predicted and actual performance score is less than negative 0.5. That means something is happening, right? So we got two employees, employee 48 and 45, who unfortunately has have their scores. And also we can find the weak collaborations between the employees. That this is the query. Weak collaboration strength is less than 0.3, and there are other functions, and the performance rating is 3.5 or other employees' performance rating is greater than 3.5. Means they are an average, so they're performing on average level, but their collaboration strength data is less than 0.3. That means they have the capacity, but they are not fully, uh, they are not being able to collaborate with each other. There could be a lot of reasons for that. So we get that. Mentorship recommendations is another thing we can. This one. So who can mentor whom? We can write a cipher query. This is getting the data from the graph database, and senior employee and junior employee, where senior employees experience is grade 8 and junior employees is junior, uh, and who never collaborated with each other. This is the condition here. So this is the first time I'm seeing a senior. So yeah, that is a different experience altogether. So this is our analysis that we perform manually, right? But here's the catch. So here you can see the mentorship recommendation. Mentor 2 can go to record, can go to mentoring, uh, can mentor like employee 39. Mentor 2 can also mentor 45. See these things. Interesting. The main catch is that we can, someone can say that, oh, this Y graph database, right? Any normal relational database, relational CSV fat files can do that too. But no, there's graph analytics that we did, predictive analytics that we did using the graph neural network that takes account the collaborative factor, the connections between each other. So that is um, the extra. That is one extra feature that the graph neural network gives you. All right. Now, if how about we want to uh, do this analysis task with an AI agent, right? So for that, we used AI. AI. Uh, Let me show you the results first. Okay, let me run the script more than that. So our AI agent connects with an LLM, a large language model called Groq, and it also does almost the same thing that we did manually. It um, pulls the data from the graph database. It uses the graph neural network model for predictive scores, finds the gap, and using the LLM, that is the good thing. Using the LLM, it gives us very well written report about the employees that we mentioned. For example, we mentioned uh, an individual employee analysis for employee two, right? So current performance evaluation does, right? Current performance rating 3.51 out of 5. And you see all the natural language happening here. That's because Crew AI is connecting, working with Groq 11 at the same time. And the Groq is Mistral. 11 is Mistral. The performance trajectory and potential. The predicted performance for employee 2 is 3.1. All this prediction suggests that the employee's performance may decline slightly over time. It also says that the performance curve of the current rating and predicting performance is C. It uses the predictions and finds out the performance gap of a particular employee. Also, it does the additional analysis as you prompt. I2 has 12 years of experience. This experience can be valuable asset for knowledge. Detailed report. Development opportunities also suggested. So this AI agent is a wonderful thing. Right? You have to do it. Although we got the analysis here, like it looks like very very like structured, but if you want to analyze this report, you have to use your own writing skills and you know. But if you give it to the LLM, like deploy some AI agents for that, it gives you the detail. Might be in some cases they're doing better than you. So okay, let's see what's the main focus of meeting expectations. The employee should continue to focus on meeting expectations of delivering high quality work. See, why high quality? Because it is why high quality work? Why is it saying that? Because it has the data from the graph database and it has that graph neural network model and it takes everything into account. That is the main magic here, right? So, address any areas of weakness. If the employees identifies any areas of weakness, they should address them proactively. So it is giving us some suggestions. Same for employee ID 4. Like you can mention number of employees here in a script. Uh, Here we mention 2 and 4. You can as much as you want. As for your LLM, yeah. So specific recommendations for employee 4 focus on refining employee skills in areas where they are slightly under. Why? They are saying that again. It has the data. It has the collaboration data also. So that is the main catch. Yeah. So this is what I wanted to basically show you, and I'm using Neo4J AI agents, uh, yeah, all that. This is a good idea to use uh, graph database if you are if you're performing analytics and if you want to take collaboration connections into account to predict something in your team uh, for individual for the whole team itself. So craft neural network meets AI agent. Uh, that's what I wanted to show you today. Hopefully, you'll see something in the future again regarding AI, RAG, knowledge graphs. I'm really interested in exploring how quantum computing can work for this generative AI thing. So let's hope for that. I will keep my ears open. So let me know if you like the video. Thank you so much for watching.